Okay, let's go over exponent laws. So we've given you some shortcuts for exponent laws. We're going to talk about them, and we're going to talk about why they work. So here it might be tough to realize because everything's written as letters. Okay? What this says, our base is x, and we're multiplying this exponent by another exponent with the base of x. We can simplify it to have just one exponent of base x. Okay? So we can replace x with any number. If this was 1, well, we can write it as the number 1 with some exponent. If it was 2, if it was 3, as long as the bases are the same, we can use this rule to simplify it. What it says from there, if multiplying them, we take the two exponents and add them together to figure out what the exponent is equal to. So we're going to do the trick, and then I'm going to show you why it works, the proof. So first of all, are these bases the same? Yes. So that means we can simplify it to just base 6. And what will I do with the two exponents? That's right, 2 plus 3. So what does this simplify into? Good, we know how to add. Excellent. Now the reason this works, okay, we'll do it up here. This says 6 to the power of 2, which is 6 times 6, multiplied by 6 to the power of 3, which is 6 times 6 times 6. Okay, do I really need those brackets involved? No, because in multiplying rule, it doesn't matter what order we multiply in. We just did it to help us simplify the question. How many 6's are there altogether here? There are 5. So essentially, we can be rewritten as 6 to the power of 5. So that's the proof for it. But we don't have to go through all those steps. Once we know this rule, we can just jump ahead, add the exponents, and get our answer. Okay, so that's our first law. The second law has to do with division. Oops, I don't know what's going on. There we go. Okay, that kind of worked. All right, so the second rule has to do with division. The same idea with our bases of our exponents. The bases of the exponents have to be the exact same. Okay? Just like the one we worked on before. This time, though, this is a division question. I've written that as a fraction, but we know this sign means division. So if we're dividing them, we can simplify it with the same base, but this time we take the exponent on the numerator and subtract it from the exponent on the denominator. In other words, the exponent on top subtracted by the exponent at the bottom. Okay? So that's how we would simplify this question. Here, come on in. So, in this question here, we have base 6. The bases are the same. If you notice, we're using the exact same numbers. We can rewrite this as just base 6. But I have to subtract the two exponents. What order do I subtract them in? So how would I write this? 2 minus 3. Good. And what is 2 minus 3? Negative 1. Okay? So this is 6 to the power of negative 1. Now, we don't really go into too much depth about negative exponents, but I want you to realize that you can get negative exponents. Okay? So if we're subtracting, we end up with a negative exponent. That's fine. Let's talk about the proof of this. And it'll actually help us explain what a negative exponent is. So this is kind of a side note here. We know from here, 6 to the power of 2 is 6 times 6 divided by 6 to the power of 3. Okay? And I know you guys haven't really talked about this, but what ends up happening is if you have, does anyone know what 6 divided by 6 happens to be? 1. So what they talk about is they call this canceling out. Because 6 divided by 6 is just going to be 1, we don't really need to write them both in. They cancel each other out. Okay? So this 6 disappears and this 6 disappears. Same thing happens again. We continue to pair them up. We're left with just a 6 on the bottom. Okay? Which means the number on top would just be a number 1. We're left with 1 over 6. Okay? Now, if there's no exponent written for this 6, what do we expect to be there? Anyone know? Just a 1. Okay? And it turns out negative exponents can be turned positive by inverting their base. Now, this is really going off track. We don't have to really focus too much on this, but I'm just showing you the proof. That we can rewrite this as this. Okay? So all that was is to show you how the proof of this works into becoming a negative exponent. Okay? Again, this is the only rule we really need to focus on for what we're doing. This is just a proof. Not imperative that we memorize. And finally, the last rule here. We have a base, and it's a power of a power. Okay? If we have a power of a power, we write the same base, but in this case, we multiply the two exponents by each other. So we have base 6. How would we write the exponents here? 2 times 3. Okay. And what does that become? 6 to the power of 6. Good. So let's say we were going to prove this. And I'm going to need a little more room to prove this one. We have 6 times 6 inside the brackets. And then that is going to be to the power of 3. Okay? So if that's to the power of 3, we know that when writing out exponents, we repeat the base the amount of times the exponent is. So I need to repeat 6 times 6 3 times. So to write that all out, that would say 6 times 6, that's one set, multiplied by 6 times 6, that's 2 sets, multiplied by 6 times 6. How many 6s do we have altogether? 1, 2, 3, 4, 5, 6. So that could be also rewritten as 6 to the power of 6. Okay? But for our purposes, we just want to memorize our rules. Okay? So I'm going to highlight the parts that are important to us. This rule here is very important. This rule here is very important. And this rule here is very important. The other things were just proving how the rules work.